Hi everyone, welcome to this modern C++ feature. Today topics, we're going to discuss about override. What is it? Let's get into it. Suppose we have two classes here. The first one is the base class. The second one is the derived class. And inside these two classes, we have the identical function called display. So in this situation, we call these two functions the overriding function because in the child class, like in derived class, we implement different things compared to the base class. Right? To make the overriding function valid, we have two simple rules here. The first one, the member function display in the base class must be virtual with this virtual keyword, because otherwise in the derived class, the display function won't be overridden. The second rule is that the two functions must be identical. This includes the name of the function, the parameters inside parentheses, the context, and the return type. Otherwise, it won't override from the base member function. So let's see in the live code and how to implement. On the right of my screen, you see the live code here. You can see I have two functions here. Sorry, I have two classes here, the base class and the derived class, which are exactly the same thing in the slide. So in here, you can notice that the member function in the base class, we have the virtual, which is necessary for overriding function. And also the function elements here, they're all the same. And the implementation different, right? The base class here and the display from derived class. So I'm gonna run this code to see how it works. In the main, I declare the pointer to the derived class. Since the derived class is inherited from the base, so I make the type of it base, right? And I call this display function. So let's see how it works. So you can see that it's output display from derived class. This is the expected behavior as we want to make the derived class work based on this display function, right? This is a simple example. Let's do some exercise. If I comment this one, and we have the exercise here, I can uncomment this one, and I can have four different function here. I'm gonna uncomment this one. So display 1 to display 4, right? So let's see. Let's see how it works by running it. Oops, what's happened? Sorry, I forgot to comment the correct one. It. So there's no errors here, right? But what's the behavior? You can see from the output that the display function, they are different and but they print out the base class. But what happened, because we use the derived class here, it should print in the function inside the derived class. What happened is that these function inside the derived class, they're not overridden. Why? Because it's not follow the rules, right? As we already talked about. So can you guess how should we fix it? So to do it, let's see each function separately. Now display one. The parents in the member function in the base class, we have the virtual, which is correct. And also the function elements in the derived class, they not the same as the base because it doesn't have the context. If I add the context here, You can guess, right? Now run it. You can see is what we want is inherited from derived class. Like display number two, we have in the base we have virtual, which is correct, and but inside the parentheses, the parameter type are not the same. That is the reasons. If I change it to the same type, what do you think? You can guess. It is also the expected behavior, right? And the function number three, display three, we have the virtual keyword, which is correct. But this is this is introduces in C++ 14. It is called, you can see the ampersand here, it is called the reference qualifier, right? I can explain it later, but here you can see that in the base class, you have just a single ampersand, but in the derived class, we have double ampersand, which is not the same. The rule is that these ampersand should be the same. If we use single in the base, we should use single in the derived class. If I run this one, yes, it's printed a message from derived class. And the last one, yeah, you can notice that display number four doesn't have the virtual keyword. That's not follow the first rule, right? Does not follow the first rule. To make it right, we can type the virtual here. See, all functions, all messages are printed out from derived class. So let's move to next slide. As in the previous examples, when we have done something wrong, the overriding function don't work, right? So when you run the code and print the output, they shows no error, right? So it doesn't have any compiler output of any errors or warning related to overriding function. So this is not proper compiler output, right? So yes, we will end up at the as in the previous example. So we will make use of like the unintended function that we don't want to use, right? The question is this a better way? How to force a compiler to give the explicit output when we don't want to use the function, right? It comes to the keyword override. We will use this keyword with the overriding functions to give the proper compiler output when we uh, don't want to use a function. So let's see how it works. I've remodified the code to add the override keyword. So in this previous example, so I will make any change to the base, right? In fact, I will delete this one. Yes, and in the derived class, I will revert it to the previous incorrect examples. So unsigned this one and this one. So, but in this version, I will add the override keyword to each member function in the derived class. So this one override. So Okay, keep this the same. Just a reminder that in the previous example, when the member functions in the derived class, they don't override from the base, there's no error shown in the output, right? But what if I implemented the override keyword here? What happened? So run the code. You can see there are several errors here related to overridden function. So this one, they don't override any member function. So they are the same error output. This is what we intend because when we want to use the function inside the derived class that inherited from the base, but the function we intend to use is the overriding function, right? If it comes the time when it doesn't match at all, right? When the member function inside the derive doesn't match the base at all, this will report and we can fix it properly. That is why we want to use the keyword override here. I will show you the real-world examples of how to use override keyword in this library, navigation tool. This is the library for navigation framework of the robot. So on the left side, this is the class follow part action. This is the class name, which is inherited from the BT action node class here. This is the template class. And on the right side of the screen, this is the class BT action node, the parent of follow part action class here. If we scroll down on this child class, we will see the keyword override. Yes, if you notice that it has the override keyword here, that means it's use the identical function in the parent class, right? For example, this onTick method, right? If in the parent class, scroll down again, you will see the onTick function, which has the virtual. It is a must, right? Scroll down again. For the on success method, it also has the virtual. Same things. It has the same return type. It has the same parameter type here, and also the override keyword. That's what we should do. If you have on the border, yeah, the same on cancel, and also have virtual on the parent class. So these are uh, the good practice of when you want to implement your code based on the parent class, right? You should do like adding the override keyword. This will make your implementation smoother. Like when you forget to add something to your function, this will report that it doesn't. This will give you an errors from the compiler, and it doesn't match to the parent function, right? Or on the other hand, if you modify on the parent side, right? You modify the function, like you change the parameter type, you change the return type, and the compiler will give you the errors because they don't match for the function on the child class, vice versa. So it's good to have the override keyword. Okay, thank you for watching here.